So on the bench here, we've got the MMD-1 unit with the MI add-on card set on top. I've already removed the card to do a closer inspection. I've just got it sitting here in place. And I'd like to do a little bit more tear down and look at this and just see what we've got. As you can see, this top board is really dusty. Let me go ahead and just remove the ribbon cable. Let's just kind of set it in place. There are 4 screws with nylon standoffs that are used to mount that board onto the case, and then underneath the board there's 4 lengths of wire, and these wires get screwed into these terminals back here in order to bring power onto the board. So, you know, it is what it is. I'm checking the camera here, sorry. It is what it is. You can see this is super dusty here. It really is pretty dusty. This is a Rev L unit, so I think it's pretty late in the life. I have not powered it up. I don't intend to power it up until I've done a bit of work on it and verified power supplies and things. So I'm going to set the main unit aside here first and look a little bit closer at this board. So let me get some brushes out here and let's do a bit of cleaning. Oh man, it's actually physically knocking dust off. I mean, in little piles, I can see it. Wow. I'm working, of course, on an or static dissipative surface. And these are static dissipative brushes, supposedly. So this should be a safe thing to do. I wouldn't recommend taking just a regular nylon or whatever brush and doing this with it, because you will generate static. And I know some people say it's not true, but static is definitely an enemy of electronics, especially older vintage stuff like this. That helped a teeny bit, but not a lot. I can smell the dust. It's just like, oh. I will probably manually clean this with the brush as best as I can, pull all the chips out, and potentially run it through a cycle in the dishwasher. If you do that, I don't use heat for drying. That's my opinion. If you want to use heat to dry, you could potentially be in an oven on a low temperature. Wow. Well, that helped, but it sure doesn't seem like it did. So what have we got here? Well, we've got excited dogs downstairs. We've got decoding logic that basically decodes the RAM. There can be 2 banks here. These are 2114s. I don't remember how big 2114 is, but there's 8 of them here. So what is that, 1K maybe? I don't even remember here. There's room for a second bank of 2114s. There is room for 4 1702s over here. Spots for these spiking capacitors, which of course aren't installed because the parts aren't there. It looks like there was a Zener Regulator here, and of course there is. This is generating the +9 for the 1702s that we don't have on the board. So it's interesting that I'm pretty sure that is regulation for the 9-volt rail. Since we don't have any ROMs on board, we don't necessarily need it. Back of the board looks okay. There's some flux down here, like maybe there's been rework. Definitely, I don't know, definitely some, I'm guessing this was added later on, looking at this. Factory soldering. This looks like machine soldering over here to me, and then manually soldered parts over here, and there's some really piss poor solder work done here as well, and over here. So I'm guessing the what's labeled modem here was added later on. So there's 2 connectors here, cassette and TTY. Man, that board's dirty. Cassette does I/O to a cassette drive, just like you'd think, so you can save programs and load programs. TTY, it provides 20 milliamp or RS-232. We talked about this a bit in the intro video. This can control the read relay on a teletype. So basically, you can tell with the load software, it'll tell the read ID to close. The teletype will start reading the paper tape and sending the data via serial communications to the system, either by 20 milliamp. Well, TTY would be 20 milliamp or 60. Well, this is 20 milliamp. It's also got RS-232 support. I'm amazed at how dirty this board is. It's just like, wow. Pins on ICs that I can see don't look horrible. There's actually, well, I say that there's 3 here that don't look great. They are TI parts, it looks like, so maybe no surprise. Trying to decide, you know, I've mentioned a little bit about stripping this board down to the bare board and maybe doing a reproduction, just so people could be able to, you know, on their MMD, use the board. Something I wanted to point out here. Oh, this is so dusty. This is an MMD-1. We've talked a bit about it before. There's the little octal keyboard here. There was the KEX ROM sitting right here. Keyboard Executive. KEX is what basically allows the system to display and take input from the keyboard and do things. And then there's an L/D ROM here, and that's load dump. That is the software that runs this board. So if you buy an MMD, and I've seen pictures of them where that ROM is there, I don't think, as far as I know, you need the board here to do the actual I/O to teletype or cassette, etc. So, you know, this unit is standing alone here, can't do any kind of data loading or saving. There's no serial on it. So, you know, that kind of is what it is. My, of course, it's an 8080A. Man, this thing's dirty. See if I can actually read a date code. Copyright 74. Man, I'm going to have to wash my hands. Oh. A0802. That doesn't make any sense as a date code. First week of 79. Looking for date codes that I can read. There's not a whole lot on here that better magnification. 14th week 78. So I mean this is definitely late. You know, in the world at this time. I mean, this is an 8080 based machine with 512 or 256 bytes of ROM by default, and 512 or 256 bytes of ROM. Say this correctly, and 512 bytes of RAM here, with an 8080 processor running at, I want to say 1 megahertz, but I could be wrong. Very simple machine. And they were still selling. I guess they were using them in the classroom in colleges and stuff, and so there was, you know, still demand for them. Even though by the date of these chips, late 78, 79, there were Commodore and other machines out there that were much more capable machines, but honestly weren't targeted at electronics education as this machine was. So, you know, this was about teaching you how to interface to a microprocessor to do real-world work in industry, you know, manufacturing, those kind of things, and to understand, you know, what's really going on at the hardware level. So, wow, that is just so dusty. Just so incredibly dusty. Looking for an appropriate flat blade. I haven't opened one of these up. I think I mentioned this in the first video. I used to own at least 3 MMD-1s. all of which had been repaired at some point and gone through some amount of restoration at my hands. Not as deep as I hope to do with this. I'd like to strip it down to the bare sheet metal and repaint the case, the metal part of the case. The silk screening on this board looks really good, so I think besides a good bath, this board's probably okay. I'm phase 2 on last pin. That may be a label we keep. Something I haven't done is take a peek at the fuse. So let's do that. That's always a good indication, or potentially good indication, of bad issues or not. So, fuse is out. Fuse looks intact. Or does it? I can't tell for sure. I guess we're going to have to measure it. Oh, some the screws flying. If you get a piece of equipment, nope, fuse is good. You get a piece of equipment and the fuse is blown, there's a reason that fuse is blown. It might be as simple as had the wrong fuse in it to there's real problems. Fuse is blown. My advice is investigate before you actually power things up. Understand why that fuse is blown if you can. So fuse is back in. So let's go ahead and rotate the top here and take a peek at what we've got, and it's exactly what I expected. So there's the phase 2 brought to the final pin there. Pretty standard inside, 115 to 230 volt transformer. It's got 3 taps, one for plus 12, one for the minus 12, and one for plus 5. I don't know what the actual AC outputs are. We could potentially measure them. A couple of full wave bridge rectifiers here. This looks like it is for the minus 12 is my guess. Hard to say which one's which. I can't really see the regulators, but let me attempt to set this aside a little bit and rotate the unit up so you can see inside of the chassis. There's 3 devices mounted in the back. There's a 78. I know one's a 7812, the other one's a 7912. Or in this case, they're LM340-12. And anyhow, plus and minus 12 are regulated here, and this is a pass transistor. It's a tip 3055, so it's a 2N3055, really common NPN power transistor in the era that becomes final 5 volt regulation, and of course there's a 5 volt regulation circuit here. Full wave bridge rectifier, filter cap. 16 volt, 2200 microfarad it looks like. An LM, I want to say 723, it might say 723 or 7230 anyhow. Voltage regulator there, 5 volt adjustment, and that produces power. So of course if this transistor over here shorts, you drop whatever this voltage across the cap is into the circuit and destroy various chips. So what I'm debating in my head is whether to keep this power supply as is or replace it with a switching supply. There's actually room where I could mount a switcher in here and leave this all in place, and it would be a more protected unit for playing with. You can see the regulated voltages are brought up onto the board here. I think I see more evidence this was probably factory assembled, and that is there's Loctite or some kind of something to keep the nuts solid on those. I see a lifted pad there with a blank pin on the 8224. I guess that pin isn't used, or they managed to get it soldered on the top. It is soldered on the top. Interesting. So something happened there. We've of course got the 8080 sitting here. I'm looking for signs of rework back here, and that's the first kind of goof I see. I don't see signs of rework. There may have been something done down here and some flux cleaned, or maybe that's from the factory. I don't know. These solder joints here are pins that connect up to the rows here in the socket here. So, we've got +5, interrupt, in out, in not, out not, memory write not, data 7 to data 0, wait, reset, etc. And there's a set of signals down this side as well, and then open prototyping area down here. I was not able to find a source for these, so they are the little 5-position pins that go into these normally, but with a pin attached to them that you can then solder to, and I was never able to find replacements for those a decade plus ago when I was looking for them. Other stuff here to mention. Anything else that I really need to mention here? I mean, we've had a pretty good look here. Oh yeah, that's the keyboard, where the keyboard passes through. Someplace I have at least one, I think I only have one left, of this style keypad that was meant to be a replacement for the earlier MMDs, where it used a different style keyboard that just didn't work well. And I ended up with 4 of the replacement or upgrade keyboards. And I believe I sold 2 when I sold off my collection. I kept 2, and I've given 1 of those away and kept 1 for me. So I do have a new old stock version of this little keyboard with these letter markings on it in my stock. Man, that's just so nasty dusty. Wow. Makes me wonder how long this set, wherever it's set. And just collect dust, and how long it's set, potentially with that board off. I don't know, with this guy off, I just don't know. So I need to start to collect up the parts we've removed here. So let me get a container for that. With the reorganization of the lab, I have got a whole lot of small organizers like this now available. We pulled out 4 from the front and 2 from the back, so I do have all the screws captured here. So that's nice. Let's go ahead and set this aside. And I mentioned this in the intro video, and I wanted to look at a little more detail here. Oh, excuse me. We've got these, what are to me oddball connectors that are used to bring cassette and 20 milliamp RS-232 out into the real world. One of those pins is really bent, and it really bothers me looking at it. I don't know if I can straighten it up or not. It looks a little bit better. And so as I looked at this, I was like, where am I ever going to get the right connectors for this? And in the build of materials, I found the part numbers for the connectors. And that led me to doing some Googling. And does this show who I bought these from? I guess it doesn't. I don't remember who I got these from. I found them new old stock. They weren't cheap. They weren't super expensive, but I did find them. I went ahead and ordered them. And I ordered one of these, the minimum quantity was 4. I think this guy, it was minimum of 4 hoods, so I went ahead and bought 4 bodies. But we've got the body here. It is keyed. So it goes down on like so. It should lock on. You have to manually put the tabs in. It locks on. So it's got the little springy guys here to lock down on. And then there was the hoods, and these are exactly what was called out in the manual. The self-assembly manual was these little hoods. And I know there's a right and left to them, I believe. I don't believe they're all the same. Maybe they are identical. right to left. Oh no, that's definitely different from this. Oh no, it's not. Yeah, I don't think there is a right to left piece. I think it's just a single piece that becomes both. Wow, is that really weird? How does that? It's got to go like so. Okay, yeah, that is how it clips on. So I see what they've done now. So we'll go ahead and clip one of these on, and hopefully I can get it off. Like so, and then there's a wire tie that wraps around down here to create the full hooded unit. Anyhow, I was really surprised to find these. New old stock. They are, I think it says on the box, maybe, or maybe it doesn't. They are a Burndy, B-U-R-N-D-Y connector. Just really interesting and different. And then I did some Googling, and on DigiKey, who is my preferred supplier, I found the proper pins. So the proper crimp pins here to finish the cable. So these are, of course, at least these better be the right ones. They seem to be. The ones that I'm assuming push down from the back here. I don't want to actually clip that in there and get it trapped. I'm not sure now. I hope those are the right pin. Do they get inserted? They may get inserted from the bottom here. They are correct this way. I mean, they make a good snug fit. Let me go ahead and free one of these. And we'll look a little closer at it. So the catches are there. I am unclear if that is really the right pin or not, or the right connector. I hope it is. It was yeah, S2COM-1KT6. That is the manufacturing part number that was called for these. So I guess once it's crimped, I'll find out which direction it gets put together. Where's my key set? Oh, it's weird when tools vanish. I have a whole set of little press over tubes for removing things like this that have been put into place, and I don't see them here where they're supposed to be hanging. So anyhow, we will in a separate video address this and build up a cable. Well, maybe it does make sense. I guess it does. So anyhow, I was really thrilled to find these. Just really cool that I was able to locate the hoods that came with the original kit, that they intended to be used to bring cassette out and TTY, RC32 and 20 milliamps. So pretty sweet. You don't need to see me try to figure out how to get that apart. It's not very exciting. 40th week of 78. We didn't really look at date codes on here. 40th week of 78. These are the two UARTs. These are 2114s. We looked at them earlier. I don't see an actual date code. I mean, there's a 2C680, I think. It's not really a date code. Sometimes just really struggle to find a date code to recognize. First week is 79. You may or may not be noticing other things here. The height of these sockets. You know, modern sockets are about half that height. This is just kind of where things were at the point in time. I have sockets similar to these that would probably be usable to stuff this all the way out. I'm impressed at how small the pads are on the front of the board and how small the openings are in the silkscreen. And anyhow, that is neither here nor there. There's of course adjustments here for mark, space, and null. I believe these two adjustments dealt with baud rate and something else, if I remember right. I could be wrong. Anything else to say here? Beyond that, board really needs to be cleaned. I'm curious what this sticker that used to be on here at one time said. It probably said property of, you know, the university or whatever. That's quite interesting. I'm just noticing that on the back of the board here, these resistor leads do not appear to be soldered. They are firmly in place, and there is solder on the front. So that must have been painful to do. So that's quite interesting. Interesting assembly technique. And it's not like light soldering like the machine soldering I see over here. I can see down into the via on several of those. Definitely a reworked solder joint there. A little bit of flux there, so something may have been done there. It looks like the spiking caps were maybe soldered by hand, although those look machine soldered. It's hard to say. It's hard to say whether this was hand assembled completely or if it was, partly machine assembled. I just don't know. I'm sure it was hand stuffed, but whether it went through a solder bath or not is a different question. Well, I think this is a good enough introduction. In the next video, we'll look closer at this board, get it stripped down, at least get the ICs removed and decide how to clean it. I'll see you in that video.